Hello viewers and welcome to a new STM32 World tutorial video. In this video I am going to teach you everything there is to know about printing in an STM32 project. Now, most of what I'm going to say in this video I have probably mentioned in earlier videos, but it sort of came in small bits towards the end of a video, and since most viewers don't watch the entire video, I thought it would be worth doing a video dedicated on this topic. The first thing you need to understand, and we have is if you look at STM32, most of you probably have an ST-Link already to do the programming, but the standard ST-Link devices, such as this one, or these that are very popular, is ST-Link V2 devices, and they don't have a serial port. So if you want serial input-output, if you're using one of these devices, you will have to use a separate USB UART thingy. And if you go to AliExpress or Amazon or whatever, you can find tons of these USB to serial or USB UART devices, and they cost absolutely nothing. So get a handful of those just to have them lying around. That's always worth it. In my case, however, what I'm doing is I made my own programmer, which is based on something ST called ST-Link V2-1. The V2-1 actually have a serial port built in, so it shows up as a dual device on USB, and it have a TX and an RX line built in on the header. So I don't really normally bother with that. I use either this one if I'm using, for example, a black pill board, or I use this one, which is the one that is stackable. So if we look at the video today, for example, what I'm doing is I'm having an STM32F405 board. That's the one on the top, and the one on the bottom is actually the programmer, the ST-Link programmer. I also still have the SD card hooked up, which is the one I used in an earlier video. So that is the hardware setup. You need some kind of serial interface, or you need the SWO, but I'm going which is part of the serial debugging protocol, but I'm going to get back to that later in this video. Now, I have created a project as usual. Let's look at this, where I am printing a statement up here that we are starting, and then in the loop I'm going to print a tick every 1 second, 1000 millisecond. Now, if I run this, absolutely nothing happens, because printf, to be absolutely honest, I don't know where it goes by default, but it definitely does not go to the serial port. So if we go in here, I have enabled the UART1 here, which is the one coincidentally that is hooked up to my ST-Link device. And if we look down at here, we are running at, today I'm running it at 115,200. It doesn't really matter. Now, in order to get that data to a serial port, to the serial port when we are printing, we need to redirect that information. Fortunately, the library, if we look at, I can do it like this, that's probably the easiest, and then right click, go to declaration. There, you'll see that this is defined as a weak function in the standard syscall C library, and that means that we can define a new one of these, and then it would work exactly like so. If you copy this and go in here, and we create it up under user code 0, we simply override this function. Now, the write function can take a character, an array, a pointer to an array of characters and a length and a file descriptor. The file descriptor can be relatively safely ignored because it is actually not used anyway, but we could use it. So let's start by doing the one you have seen me do this exact one before, which will look something like hang on, there. It'll look something like this. Let's analyze what we're doing here. We're having an H status, which is the hell status. We will, if we're looking at the file descriptor, will be either 1 or 2, depending on its standard out or standard error. Doesn't matter. You could also safely ignore this. And then we try to transmit that buffer on the UART. And if we get hell okay, then we return the length. Anything else will return -1 to signal to the standard I/O that this went horribly wrong. So let's try to go into my window here, fire up a terminal. We are not going to set the speed in this case. Yeah. So there, it's running. So let's try to build this project. Build project. Something went wrong there. Oh, I normally, okay. Let's call it FD. It doesn't matter. That's what I usually call it. Build project and fire that up. There, we get our starting and we get our tick every second. So that is how you redirect to a standard port. There is actually another way of doing this. We can see this write function is actually called by printf, but write in itself, if we look at, I don't know if I can do it like this, open the declaration I had before. I had to then comment this out because I and open declaration. It's not going well. Okay, if we look at this, you can see that it actually, right in itself, is going through this buffer one by one, and then it uses IO put char. So if we look at IO put char, is also defined as a weak function, but that one, contrary to the write, does not take an array, it just takes one character. So an alternative to our _write function, we could just as well implement it like this. We overwrite the IO put char one character at a time, and we send one character to the UART. And then let's give that a shot. Try to run that. There you go. So that is how to redirect to a standard serial port any one of the 4, 5, 6 UARTs on the device can be used. It depends on where you hooked up your USB to serial. In my case, by default, without changing them, I'm hooking him up to the standard PA9 and PA10, which is the standard UART 1 redirect. I think these can most likely, no, not really. So it's okay. It depends. You can hook it up any way you like. So that is 2 ways of redirecting these. You can override the IO put char, or you can overwrite the write. I would generally say that since the write standard library actually call the put char, I haven't analyzed this in depth, but I would say that if we do it this way, we actually save a function call, so we save a bit of stack juggling. So it's probably the most efficient way of doing it, but who knows? I haven't analyzed that. So there. Now, a thing that often gets off newcomers is, let's say we didn't do it like this, but we just wanted to print a dot. No new line, so we just want to print a dot every second, and we try to run that. You will see, and this might be a bit of a surprise, that actually nothing happens with that dot. It doesn't get printed. Now the reason for that is that printf by default is buffering all output, and it won't actually transmit it until it hits a new line. Then it will send that line. So it's actually printf is basically line based. There is a way around this, and that way would be that we do a flush. So after we print it, we can flush this buffer, and it is standard out by default. So we flush standard out. Now if we try to run that, you will see that it actually prints the dot every time. There is you can also disable the buffers. Now, rather than flushing like we do here, we can simply disable the buffer on standard out, and we can do that. Well, up here, for example, we can say set buff standard out null. So we simply disable the output buffer. So now we don't use an output buffer, and we print those dots. Let's see if that is working. And you see that works exactly like it did when I flushed it. So now every single character gets flushed out. That is, of course, less efficient if we want to print a lot, but it does work. So there are multiple ways to do these things, multiple ways to skin a cat. I mentioned that before. Anyway, let me disable this and go back to our standard showing this, and let me remove this one again. Now, there are other ways to do serial output, and the first one I want to mention here, and I have mentioned that in other videos, is essentially using the built-in debugger. So if we go into here, I have enabled the SWO port that happens up under SWO. Rather than putting serial wire, I say trace asynchronous SV. Don't know what that means. Doesn't matter. Now, this, the way that works is, where did I put that? We can basically take our put char, and we can override our put char. Let's do that. And instead of doing any of this, we can override our IO put char and send it to the ITM send char command. Now the ITM send char command, if you look, it transmits a character via the ITM channel 0, and it just returns when no debugger is connected. So this gives us a possibility of actually showing debug output, but if this system runs production somewhere and there's no debug connected, the characters are just dumped into the big void. Now the drawback of this approach is that it requires us to run it through a debugger. So what we'll do is we'll fire up the debugger. Here it always stops at the beginning, so we go over and we let me show you data console. So it is up here in our Windows show view there. Data console is there. So you add this window, you need to go into the configuration of this, and you need to enable channel 0, because channel 0 is the one that is being used for this, and you need to start the capture. It's a little bit hard to see, but there we start the capture, and then we continue the execution, and you will see we get our serial output down here. Now, this method will work without a UART USB to serial device, but it requires the SWO pin to be connected to, in this case, PB3, because that's where that goes by standard. So just a different way of achieving the same result. The final way I want to see this is if you don't have a USB UART and you don't have an ST-Link with the SWO pin, you could also use USB for this. So in STM32, if you have a USB port, let me show you that before I go any further. So in my case, I am using, it could be, for example, the black pill board. The black pill board have a USB connected to the right pins, so this would work on a black pill board. I am using this one, and again, that one have a USB port. If you look at the video there, you can see that I actually have something hooked up to that. So that is okay, it's hooked up to my desktop. So let's try to enable the USB in device only mode. No settings here needs to be changed. It just needs to go to device, and then we need to go down here under the middleware, and you will see down here you have USB device, and our device, we could set that to a virtual COM port. Let's give it a manufacturer, STM32 World, and a virtual COM port. Now let's try to generate the code for this. Go in here. Now we're not going to need this anymore, so I'm going to kill microcom, but I'm going to show you the output of the kernel messages. So that looks like that. And now let's try to here, let's try to run this. And there it comes up. So you can see that when this starts now, it will see a new USB full speed device, and that will be a virtual COM port, and that virtual COM port will create, in this case, TTY ACM1. So how do we use that in the code? Let's we could kill that, and that means we can run our microcom onto TTY ACM1 instead. Now, how do we use that in the code? Well, as you suspect, we simply need to make a few changes. First of all, in order for it not to complain about it, we need to include USB-D CDC IF header, and and as you might have guessed, we simply need to override this one. So we create a new write rather than sending to hell UART transmit as we're doing here, we'll simply use CDC transmit FS and then send it up. There is the CDC transmit will take a buffer and a length, so that one is easy. But it needs to, if there's an error, you need to return 0, otherwise it'll end up hanging. So let's try to run this. Now, this will show us one of the drawbacks of this approach, and that is that the TTY device, the serial device, disappears every time you restart, and you need to reconnect, but it works just the same. So, but if I reflash the device, it immediately disappears, and I need to reconnect to the TTA. So that was 3 or 4 different ways of getting serial data to our workstation with STM32. Now, in my case, because I have it, I would almost always by default using this approach with the UART. It's just I don't need to connect an external USB to serial device, so this approach is usually the easiest for me, the simplest for me. So that is my go-to serial console. If I need a serial console, I can also debug, single-step debug in this. I will commit this STM32 World Serial Print project, and you can go and see. I'll leave all the examples in here commented out, so you can play around with these things, including the buffer, the flush. So you can play around this, and I urge you to play around with these things. It is the way you learn, is to get your hands dirty. So fire this up on whatever development board you have, and with whatever ST-Link or IO USB to serial devices you have lying around, and get it up and running and play around with the limitations and possibilities. And that is about it. As usual, if you got this far and you like this, please do like and subscribe down below. Please comment. I love to receive comments. Now, I'm still learning to make these videos, and I don't know if I go too much in depth or I skip over some things you would like to, please comment. The last video at this time I'm recording this was actually about SD cards, and that was a result of a user request. So please do put in your comments below. I read all of them and I usually comment on them, so please do. And that is about it. As usual, have a wonderful rest of the day.